Hello everyone, in this video I'm going to go over questions relating to inverse sine, inverse tangent, inverse cosine. I've been having questions about when we do problems such as these, how do we keep track of the quadrants that we're in and obviously get exact answers. So this is a summary of the material that we've gone over, or that we need to do problems such as these over here. So for when we do composite functions, that's what these are. Composites of inverses, such as inverse sine of sine, sine of inverse sine, and so on. You notice that if they're composites, if they're inverse functions, then the rule is if I take the composite of each other, they come out to be x. And that's true for all of these, as long as the value inside of the parentheses, so in each case, the value here, here, and here, matches the domain listed on the right. So let's look at this first one. Inverse sine of negative square root of 3 over 2. I like to think of these in the reverse sense. So if, in fact, let's make this equal to some value, and we'll call it theta. Now I'm using theta because generally this is referred to as an angle. So I can say then that sine of this theta is equal to negative square root of 3 over 2, just by rules of inverses. So if that's true, we need to think, well, what sine of what angle measure will give us this response? And one thing we can do is to create a triangle. So I've moved my tangent down to give myself some room. So here's my triangle. It's a right triangle because I know I'm working with sine. And I put theta down arbitrarily. Let's put it right there. So based on this, we have opposite over hypotenuse. Oh, excuse me, I had that backwards. What do you say we try that again? So here's our opposite, and here's our hypotenuse. Now if we use our Pythagorean theorem, we'll know that this remaining side is 1. And obviously it's not drawn to scale. This, though, is my 30, 60, 90 triangle. And that implies that the angle that I'm referring to up here is going to be 30 degrees. If you remember, your 30, 60, 90 triangle is traditionally drawn like so. 1, 2, square root of 3, where this is the 30, and this is the 60. So this implies that if this theta between 1 and 2, it's up here, so I should say 60 degrees, excuse me. So 60 degrees is what we're dealing with. So let me erase this. I'm dealing with 60 degrees, or I'll say pi over 3. Now what we have to consider is what quadrant are we in, and that's the thing. Because we can't just say pi over 3 because that's assuming we're in the first quadrant. So this is where we have to look. This is where these domains and ranges come into play. If I take this information over here for my sine, this tells me that the sine of this angle is going to be negative. So we have to think, where is sine negative? That's going to be in quadrants 3 and 4. Now we look at our inverse function here on the outside, which says that we're dealing with inverse sine. So if we look back, inverse sine, we're talking about the interval from negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2 refers to quadrants 1 and 4. So the overlap here is in quadrant 4. So this tells us we're in quadrant 4. So being in quadrant 4, we're saying what is pi over 3 in quadrant 4? You have a couple options. You could say well, that's pi over 3. We could say it's negative pi over 3. Or if you're going the other way, we could say it's positive 5 pi over 3. And depending on your instructor or what you're trying to get, either one is an acceptable answer. So we can say negative pi over 3 or 5 pi over 3. So these are all things you want to consider. Now if I want to do inverse tangent of square root of 3 over 3, let me give myself some more room. So again, equals some value theta. I'll say it's equivalent to saying tangent of theta equals square root of 3 over 3. I can make a triangle. Opposite over adjacent. So 3 square root of 3. Now use my Pythagorean theorem. I'll say this would be square root of 12, or if I reduce it to square root of 3. Now you may or may not recognize this, but this is our 30, 60, 90 triangle. The reason we can confirm this is, if you remember 30, 60, 90 triangles, there's always a relationship. So 1, 2, square root of 3. So in other words, if I multiplied each of these values, 1, 2, and square root of 3, by square root of 3, I'd have this triangle. As you can see, I have a coefficient of 1 here, 2, and 3 is equivalent to square root of 3 times square root of 3. So we have our 30, 60, 90 triangle. Now I want to say, I need to put my angle in. So if my angle is over here, that corresponds to my 30 degrees. So we're saying we're looking at, I need some more room, pi over 6, 30 degrees as a possible answer. Now we need to consider our ranges. Range and domain. So since this is telling us tangent of theta is positive, tangent is positive in quadrants 3 and 1. Now, looking back at our domains, our modified domains, for inverse tangent, we're looking at the domain from negative pi over 2 to pi over 2. Just like with sine, that's quadrants 1 and quadrants 4. So our overlap is here in quadrant 1, so this tells us it's positive. Pi over 6 in the first quadrant, it's just going to be pi over 6. So this is our answer. So these are two examples of how we can use inverse sine, cosine, etc. to find composite values. Or first of all, I should say, to find exact values of inverse functions.